We're going to be looking at a technique referred to as completing the square. Very useful when you're dealing with quadratics because it allows you to do things like, for instance, change a standard form equation into vertex form. You remember that vertex form allows us to know exactly where the vertex is. Let's start by looking at how we square a binomial. Now remember that a binomial is two terms, and when you square those two terms, there's a standard thing that happens. You're going to end up with, first of all, three terms, and those three terms are the square of the first term plus, so that's why the x here becomes the x squared, plus you're going to get a middle term, and that middle term comes from taking the 5 and the x, multiplying them together and then doubling it. So we're going to end up with 10x. And then we're going to take the last term, or the second term, and we're going to square that, and that's where the 25 comes from. Here are two more examples. If I were to take 3x plus 4y and square that binomial, I'm going to have the 3x becoming 9x squared. So you square the 3, you square the x, you get 9x squared. You square the 4 and you square the y, that gives you the 16y squared. What about the middle term? Remember that middle term comes from taking these two terms, multiplying them together, which would give you 12xy, and then doubling that. That's where the 24xy comes from. Second example, if I had 7 minus 2x and I'm squaring that, I'm going to have the 7 being squared to 49. I'm going to have the minus 2x, when you square that, becoming positive 4x squared. Now notice that it becomes positive because even though it's a minus, when you square it, it becomes positive. The middle term, again, is these two things multiplied together. So 7 times minus 2x, of course, is minus 14x, and you double that to minus 28x. So there you go. How do we therefore create a perfect square? Well, if you started off with 8x and x squared, the question is, what term do I add on to the end that makes this into a perfect square? So I can write it as a binomial squared. Well, if we sort of go backwards from what we did before, that middle term comes from taking double the product of the two things. So if I were to divide that by 2, and remember the last term comes from squaring the number that we had in the bracket. So if I were to take that and divide it by 2, which gives me 4, and square it, that should give me the number on the end. In fact, here comes the number on the end. It's 16. Which makes sense, because if we were to now try to factor this, which is x plus 4 all squared, we're going to get back this, because you're going to have the x being squared to give you x squared. You're going to have the x and the 4 being multiplied together when you double it to give you 8x. You're going to have the last term here squared, which gives you the 16. So it makes perfect sense. Let's try another one. What can we add to x squared minus 14x to make that into a perfect square? Well, again, we're going to take this term here, which is like what was your middle term, and we're going to divide that by 2, and we're going to square it. So if you divide that by 2, it gives us minus 7, and when you square that, it becomes, of course, 49. Now, does that make sense? If we were to square x minus 7, would we get this back? Well, let's see. The first term is squared, gives us the x squared. We multiply these two together, which gives us minus 7x, and you double that to give us minus 14x. And then the last term is squared, so that minus 7 gets squared and gives you 49. So it makes perfect. Let's use this technique to see if we can change from standard form to vertex form. Here's our first example, x squared plus 8x plus 15. We're going to, first of all, add something onto that x squared plus 8x. That's going to give us a perfect square. Leave the 15 out here for now, because that's not going to be a perfect square at the beginning. But if we add something onto here that could give us a perfect square, then we would have a perfect square plus or minus something on the end here. The thing that we're adding on, of course, here is 16. Remember, divide that by 2 and square it. So I'm going to add on that 16, but of course if I just add on 16, if I want to make this equation still be balanced, I have to minus a 16 over here as well. So there's a plus 16 here, so these three terms will give me a perfect square, and then I'm minusing 16 over here to keep that all nicely balanced. Well, the first three terms can be squared into x plus 4 squared. So we take half of that put a squared here. If I multiply this out, I will always get back the x squared plus 8x plus 16. So this part here represents these three terms. But then we still had the 15 minus 16 out here, and that's going to give us minus 1. So what we have is a perfect square and then plus a constant or minus a constant. So in this case, it's x plus 4 squared minus 1, which is really our vertex form. And therefore, our vertex is at minus 4, minus 1. We can verify that with a graph. Look at example 2. Same kind of thing, but this time we now have something in front of the x squared. Well, we still want to make it look like what we had before. So why don't we factor out that minus 2? If we factor out that minus 2, divide this by minus 2 and that by minus 2, we're going to end up with x squared. Divide that minus 2 into a positive 12x, you're going to get minus 6x. So now we have these two terms, just like we had those two terms up here, and we're going to see if we can add something inside of this bracket to make this into a perfect square. What can we add in? Of course, that would be 9. You divide this by 2, which gives us 3, or minus 3, and we square it, that gives us 9. But again, we have to add 9 and minus 9. We can't just add a 9 into the bracket, because that means that we've changed it unless we add a 9 and subtract a 9. So it's exactly what we're doing. We're adding a 9 and we're subtracting a 9. But this other 9 here, this minus 9, doesn't belong in our perfect square. We have to put it on the outside of the bracket. But there's a minus 2 in the front. We have to bear that in mind. So we have to know on the next line, multiply this minus 2 by this minus 9, because everything inside the bracket gets multiplied by minus 2, and what we get from that is positive 18. We're going to put that positive 18 outside the bracket out here. So this first part here, just these first three terms are going to stay inside the bracket. The minus 9 gets multiplied by the minus 2 to give us positive 18 outside the bracket. But these three terms that are left do give us a perfect square, and here's the perfect square right here. Minus 2, x minus 3 all squared. That's your perfect square right there from taking just these first three terms. Now the minus 7 and the plus 18, which we talked about before, that's going to give us positive 11. So what we now have is vertex form. Minus 2, x minus 3 squared plus 11. Our vertex, therefore, is at positive 3, positive 11. Let's use that same technique to solve a quadratic equation. But we're not going to do it by factoring. We've solved quadratic equations before by factoring. We're not factoring this time. Let's take this example. X squared plus 6x minus 7 equals 0. Well, why don't we, first of all, take that minus 7 and add it to the other side. So just left on the left-hand side with the x squared plus 6x. Then let's see if we can add something to that side to complete the square. We're going to add a 9 to this side, but to keep this balanced, we have to add a 9 on the other side as well. Remember, if we do the same thing on both sides, then we're good to go. So why do we add a 9 here? Because remember, that's what completes the square. If you divide 6 by 2, which is 3, and square it, you get 9. So that means that this side will become a perfect square, which we'll do in a minute. And the other side takes a plus 9 so that the two sides are still balanced. Okay, so we made a perfect square out of it. Let's actually put it into a square. So this x squared plus 6x plus 9 becomes x plus 3 all squared. And that's equal to 16. The 9 plus the 7 together give us 16. Well, what's next? Why don't we square root the two sides now? If we take the square root of this side, and we also have to take the square root of this side. When we square root something which was already squared, it removes the square. So we're left with just simply x plus 3. The other side, though, when you square it, becomes plus and minus 4. Don't forget that when you square root something, you're going to get two answers. So the square root of 16 is actually plus 4, but also minus 4. So here's what this means. We have two answers. We have that x plus 3 is equal to a positive 4, and x plus 3 is equal to a negative 4. That's where the plus and minus 4 went. Two equations. The same x plus 3 is equal to both of them. It's equal to positive 4 and negative 4. Let's do one side at a time. X equals 4 minus 3. I just simply minus the 3 from the two sides of the equation. and I'm going to do the same thing on the other side. I'm going to minus 3 over here, so minus 4 minus 3. On this side, x is equal to 1. On this side, x is equal to minus 7. And those are your solutions. X equals 1 and minus 7. Let's use that to solve a quadratic equation again, but this time we can't even factor. Okay, so even if we wanted to try to factor, it wouldn't work. X squared minus 10x minus 5 equals 0. We're going to put that 5 on the other side. We're going to add the half of minus 10, which is 5, and squared, which is 25, on that side, but also on this side. Then we're going to make these three things into a perfect square. So that, of course, is x minus 5, half of the 10, x minus 5 squared. On the other side, we get 30. 25 plus 5 is 30. So x minus 5 squared is equal to 30. We're going to do the same thing as before. We're going to take the square root of x minus 5 squared and the square root of 30. So when you take the square root of x minus 5 squared, you get this x minus 5. It removes the square. On the other side, we're left with this plus and minus 30. Remember, it's two answers that we're going to get. Now, we don't know exactly what the square root of 30 is. On your calculator, you're going to get some number with decimals in it. So really what you can do is you can write the answers in what we call exact form. So we'd have 5 plus the square root of 30 as one answer, and 5 minus the square root of 30 as our other answer. These are exact answers. If you wanted to get more sort of rough estimates of the answer, so they're not exact anymore, they involve having to actually take square roots, it would be approximately, that's what this little strange curly looking equal sign means, that x is approximately 0.477 and 10.477. You can try that on your calculator by taking the square root of 30 and adding it to 5, and taking the square root of 30 and subtracting it from 5. Those are the two answers that I got using my calculator. So these are exact answers, and these are reasonably close approximate answers. Let's try this again, but the difference now is that you have that 3 in front of the x squared. We're still going to add 5 to the two sides. Going to take the minus 5, bring that over. Now, remember the last time when we had that 3 in front of the x squared, we factored it out. We're going to do the same thing here. So we're going to factor out that 3, leaving us with x squared plus 2x. All right. Then we need to find something to make this inside here become a perfect square. So we're going to add 1 and subtract 1. Remember, that plus 1 is what we'd get by dividing the 2 by 1 and squaring it. There comes your plus 1. So we have 3 times all of these things. We don't need this last term in the bracket. We just need these 3 to make a perfect square. So I need to put that outside the bracket. So I'm going to take that 3 times that minus 1, which of course gives me minus 3. So now I have this part here which became a perfect square. These 3 terms can become a perfect square. I have the minus 3 out here, which is taking the 3 times the minus 1, and that's equal to 5. So I'm going to add that minus 3 onto this side to give me 8. And so now we have this times this squared is equal to 8. I'm still trying to solve for x. So what I'm going to do is I'm going to divide the two sides by 3. So I'm going to divide this side by 3 and divide that side by 3, leaving me with 8 over 3. Now I need to square root like we did before. Square root this side because it's now something squared is equal to something else. So we square root this side and square root this side. And now this side, of course, doesn't need the square anymore. So we're left with x plus 1, but it's equal to the square root of 8 over 3. We've not seen anything as scary looking at this, as this before, but there you go. So we're going to take the plus square root of 8 over 3. We're going to minus 1. This 1 here gets minused. And then we're going to take the square root of 8 over 3, and then we're going to make that a negative, and we're going to minus 1. These are exact answers again, as we did before. So now we can get approximate answers, which is that it's approximately equal to, again, using that little squiggly sign, 0.633 and minus 2.633.